Hey everyone! So imagine we are at a supermarket. We're gonna be encountering multiple various quantities over there. For example, 1 kilogram of flour, 200 milliliters of some juice, and perhaps a dozen of bananas. We are measuring these quantities in various units. For instance, mass of flour, volume of the juice, and number for bananas. But what if we are actually concerned with the particles over there? It's going to be a really huge number of particles, atoms, molecules, ions, whatever. So here we are going to be talking about moles. So moles is actually the amount of substance that has exactly 6.022 exponent 23 particles. Now the particles of matter are really small. We are talking about atoms over here, we are talking about ions over here, or perhaps we are talking about molecules over here. And this 6.022 exponent 23 is a fixed number in 1 mole of literally anything. Of anything. For example, if I were to talk about 1 mole sodium atoms, or for example, if I were to say, let's suppose 2 mole, I don't know, copper plus 2 ions, or perhaps 5 moles of hydrogen molecules. Every time we would know that 1 mole sodium atom has 1 times 6.022 exponent 23 sodium atoms. The 2 mole would have 2 times 6.022 exponent 23 copper plus 2 ions. And in the case of hydrogen, we'd be having 5 times 6.022 exponent 23 hydrogen molecules. They have one thing in common. Every time the value of 1 mole remains the same. 1 mole particle is exactly the same value no matter how many moles we are actually dealing with. Now, let's imagine, for example, if we have hypothetically 1 dozen eggs and 1 dozen oranges. They both have the same number of eggs and here oranges. But do they have the same mass? The mass of these 12 eggs is not equal to the mass of these 12 oranges. And there is a reason, because an individual egg is obviously much lighter than an individual orange. Similarly, we should know the fact that 1 mole of, for example, hydrogen has the same number of particles as 1 mole sodium atom. They both have 6.022 exponent 23, and this is the same number both sides. But one thing is very interesting, that the masses of these substances are not same. So for example, if I were to have, let's suppose, 1 mole if I were to say 1 mole hydrogen atom on this side, and for example if I had 1 mole sodium atoms on this side, for example, if I had 1 mole hydrogen atom with all its 6.022 exponent 23 particles and 1 mole sodium atoms on this side, their masses would be different. Their mass would be different because individual hydrogen is much lighter than individual sodium atom. So we should know the fact that mass of 1 mole is individual value for each element, is individual and unique value for each substance. Now, this leads us to the concept of how do we find out how many moles are there. For that, we have things easier, right? How we have it? Let's see. When we want to find out moles, we have matter present in three states of matter, which are solids, which can be liquids, or it could be gases. We can be measuring matter in these three states. For solids, we go for mass measurement, which is normally grams. For gases, we normally measure volume, which is measured in centimeter cubes or decimeter cubes. And for liquids, we have a very unique concept known as concentration. We will be talking about concentration very soon, but currently we are just writing the unit of concentration. We can be measuring our matter either in the solid state, mass of the solid, we can be measuring the concentration of liquids, or we could be measuring the volume of a gas. In the next video, we are going to be talking about how do we find out the moles from a given mass or a given volume or the concentration of liquid. So in today's video, we just talked about how mole has the same number of particles every time, and the same number of particles may have different masses if the individual substance is lighter or heavier. And then we talked about the fact that we can be calculating moles from three different states of matter based on what kind of quantity we are actually measuring. So stay tuned, guys.